Homework 4.4, Exponential and Logarithmic Equations, Video 7. Homework due Friday, May 29th, 11:59 p.m. This video and the following video are associated with questions 16 through 20 in the homework. In the previous two videos, we solved log equations that had logs on one side. And as was kind of discussed, the other type is having logs on both sides, such as this example. Log of x plus log of 13 equals log of x plus 13. Now I like this one in particular because a lot of people make up their own rules, which usually aren't good. One of them is, if I'm going to add two logs, let me just add their insides. Nope. We do have a rule that says what to do here, but it doesn't say that. The product rule says you would multiply the arguments, not add them. So this is not a property, this is an equation to solve. Now you may notice that I've still got the same list that I had from the previous two videos on how to solve logarithmic equations, logs on one side. The reason it's still there is because the list for solving logs on both sides is very similar. I just have to make some minor changes. So if you're going to take notes, don't write this down until I tell you, now it's good. So first, let's change it to logs on both sides. The first move is pretty much the same. But since we have logs on both sides, we need to amend the first step to say, if necessary, condense into one log on each side. So our goal initially in the first step is to get one log on each side. In this one, we already have one log on the right side, so there's no need to condense over there. But on the left side, we have the sum of two logs, so we can use the product rule. Product rule, which says the sum of two logs is equal to the log of the product of their arguments. I could write x times 13, but it looks better as 13 times x, which looks even better as just 13x. So product rule, put them back together by multiplying their arguments if there's a plus in between. So what's the next step? Rewrite an exponential form? Well, we could, but the answer to this log is another log. So if we rewrote an exponential form, this would be in an exponent. And even though that's manageable, let's take advantage of the fact that logarithms are 1 to 1. Well, if there happens to be a really, really slick but annoying mathematician watching this, you could call me out on that. Let's just say that log base 10 is 1 to 1. Actually, it is. Yeah, okay. Sorry, my mind was going off in a way theoretical direction, so please just delete the last 30 seconds from your memory. Log functions are 1 to 1, meaning that their graphs pass the horizontal line test, and also meaning that the only way two logs can give the same output is if their inputs are equal. So in other words, if this log is equal to that log, then that means their arguments are equal. So 13x and x plus 13 have to be equal. So we really don't rewrite an exponential form here, and this is the other change, and this is the last change. So after this, the list will be correct. The second step, when you have logs on both sides, after condensing, is not to rewrite an exponential form, but cancel logs and equate arguments. Equate being a verb, meaning to set equal to each other. So cancel the logs, but not until there's only one log on each side. One log on each side, you can cancel them. Only if there's one log on each side. The last two steps are the same. Finish solving, discard any solution that makes an argument non-positive. If I were to solve this, I have too many x's. I have them on both sides. Let me get rid of the smaller one. I invite you to solve that while I walk over here and get a drink of my Pepsi Zero. So have you solved it yet? Subtract, guess I'll just bring this with me. There's no crime in drinking this Pepsi Zero in this video. It's not like I'm getting any compensation from them or anything. 13x minus x is 12x. 13 comes down, finish solving by dividing by 12, and you get x equals 13/12. But before we christen it a solution, we need to inspect it to make sure that it doesn't cause any argument to become non-positive. This is an easy inspection. This is a positive number here. Putting it here, it's still positive, so it's okay there. Putting it there, I add 13 to it. If I have a positive number and add 13 to it, it's still going to be positive. Notice I didn't calculate 13/12 plus 13, because I wasn't trying to do that. I was just making sure that it kept the argument positive. It's a keeper, that's the solution. By the way, if you get one solution and have to throw it away, then the equation has no solutions. One more, and then we're done with this series of videos. That was quick.